Welcome to part 12 of Applied Chemistry, where we'll discuss about solid waste and its management. Solid waste pollution refers to the accumulation of unwanted, discarded materials in the environment that are not biodegradable or have a slow decomposition rate. In this section, we'll discuss the classification and sources of solid waste, its effects on the environment and human health, and the various methods for treating and disposing of waste. Solid waste can be classified into several categories. Municipal solid waste, MSW, this includes household and commercial waste, such as food scraps, paper, plastic, glass, and packaging materials. Commonly known as garbage or trash, it accounts for much of the waste generated in urban areas. Industrial waste. This comes from manufacturing and industrial processes. It includes chemicals, metals, and toxic substances, along with construction debris. Managing industrial waste is critical due to the hazardous materials it often contains. Hazardous waste. Hazardous waste poses significant risks due to its toxicity, reactivity, ignitability, or corrosiveness. Examples include pesticides, batteries, and certain chemicals used in industries. Improper disposal can lead to severe environmental and health risks. Biomedical waste. Produced by hospitals, clinics, and laboratories, this waste includes sharps such as needles and scalpels, infectious waste like blood and body fluids, and pharmaceutical products. Handling biomedical waste requires stringent protocols to prevent infections and contamination. E-waste. This refers to electronic waste, including discarded computers, phones, and other devices. E-waste contains hazardous materials like lead, mercury, and cadmium, which can leach into the environment if not properly managed. Solid waste is generated from a variety of sources. Residential areas. Households produce waste like food scraps, plastic packaging, broken appliances, and garden waste. Industrial and commercial establishments. Factories, businesses, and construction sites generate large amounts of waste, including scrap metals, plastics, chemicals, and building materials. Agriculture. Agricultural activities produce crop residues, animal manure, and chemical containers, contributing to the solid waste burden. Healthcare facilities. Hospitals and clinics produce biomedical waste, including disposable medical supplies, chemicals, and pharmaceutical waste, which require careful disposal. Electronic industry. The rapid increase in the use of electronic devices has led to a surge in e-waste, which contains toxic heavy metals and rare earth elements. Improper management of solid waste can have serious consequences for both the environment and human health. Environmental effects. Land degradation. Accumulation of garbage in landfills occupies large tracts of land, damaging ecosystems and reducing the availability of fertile soil. Air pollution. Open burning of waste produces harmful pollutants like dioxins and furans, which contribute to poor air quality. Water contamination. Leachate from landfills and open dumps can seep into groundwater or nearby rivers, contaminating water sources with hazardous chemicals. Soil contamination. Toxic substances, particularly from e-waste and industrial waste, release harmful chemicals into the soil, affecting plant growth and reducing soil fertility. Health effects. Disease spread. Poorly managed waste provides breeding grounds for disease-carrying organisms like mosquitoes, rats, and flies, increasing the spread of diseases like malaria, dengue, and cholera. Respiratory problems. The burning of solid waste releases toxic fumes, leading to respiratory problems like asthma and bronchitis among nearby populations. Heavy metal poisoning. Exposure to heavy metals from improperly disposed e-waste and industrial waste can lead to long-term health issues, including neurological damage and an increased risk of cancer. Various waste treatment and disposal methods are used to reduce the volume of waste and its impact on the environment. These methods are grouped into biological, physical, and thermal processes, as well as recycling and reuse strategies. Composting is a biological process that breaks down of organic waste, such as food scraps, yard trimmings, and manure, by microorganisms under controlled aerobic conditions. The result is nutrient-rich compost, which can be used to enrich soil. Advantages: composting reduces landfill waste and produces valuable compost for agriculture. Limitations: it is not effective for non-biodegradable waste, such as plastics and metals, and requires proper management to avoid foul odors and pests. In sanitary landfills, which is a physical process, waste is compacted and covered with soil to minimize exposure to air and control odors and pests. Modern landfills are designed with liners to prevent leachate from contaminating groundwater. Advantages: effective for managing large amounts of waste, especially when designed to prevent groundwater contamination. Limitations: requires large land areas and can generate methane gas, a potent greenhouse gas. Thermal processes: incineration. Waste is burned at high temperatures, reducing its volume by up to 90%. The heat produced can be used to generate energy in waste-to-energy plants. Advantages: reduces waste volume and generates energy. Limitations: can release toxic emissions like dioxins and furans and requires expensive pollution control systems. Pyrolysis and gasification. These processes heat waste in the absence or limited presence of oxygen, producing syngas, which can be used as fuel. Advantages: lower emissions compared to incineration, with the added benefit of energy production. Limitations: high operational costs and complex technology. Recycling involves processing waste materials like paper, plastic, glass, and metals into new products. Reuse means using items multiple times for the same or different purposes. Advantages: recycling reduces the demand for raw materials, conserves natural resources, and decreases energy consumption. Limitations: not all materials are easily recyclable, and some processes can be costly depending on the waste type. In conclusion, solid waste pollution is a global issue that requires effective management strategies. Solid waste can be classified into municipal, industrial, biomedical, e-waste, and hazardous waste, each with different sources and characteristics. The environmental effects of solid waste include land degradation, air and water pollution, and soil contamination, while health effects range from respiratory problems to heavy metal poisoning. Various methods, such as composting, sanitary landfilling, incineration, pyrolysis, and recycling, are used to treat and dispose of waste, each with its own benefits and limitations. Addressing solid waste pollution is crucial for protecting both the environment and human health. We've reached the end of this video. Thank you for watching, and don't forget to like and subscribe for more tutorials on applied chemistry and other exciting topics.